Hello, in this lecture we will find the area of the green circle. In the drawing we have triangle ABC, and inside the triangle we have the green circle that is inscribed inside triangle ABC. We know that side AB of triangle ABC equals to 13 units, and side AB is tangent to the circle at this point. We will define this point as point D. Again, point D is the launch point between the tangent AB and the circle, and we will define side AB of triangle ABC as A, and we know that A equals to 13 units, and again side point D is the launch point between the tangent AB and the circle, and side AC of triangle ABC equals to 14 units. So we will define side AC as C, and we know that C equals to 14 units, and we also know that tangent AC is tangent to the circle at this point. We will define this point as point E. Again, point E is the launch point between tangent AC and the green circle, or it is the point of tangency between the tangent AC and the green circle. And we also know that BC equals to 15 units, and side BC is tangent to the circle at this point. We will define this point as point F. Point F is the launch point between the circle and the tangent BC, and we will also define BC as B. That is to say, B equals to 15 units, A equals to 13 units, and C equals to 14 units. And we want to find out the area of the green circle. First of all, we will find the area of triangle ABC, and we will define the theorem of semi-perimeter. What is semi-perimeter? Actually, semi-perimeter of any triangle equals to the perimeter of the triangle over 2, or semi-perimeter of any triangle equals to the sum of its sides, that is to say, the sum of the sides of triangle, for example, the following triangle that has side triangle ABC, we know that side AB of this triangle equals to A units in size, side BC of this triangle equals to B units in size, and side AC equals to C units in size. Then the semi-perimeter of this triangle will be equal to the sum of its sides, that is to say, to A plus B plus C over 2. Okay? And we define semi-perimeter with the letter S, that is the abbreviation for semi-perimeter. So S, the semi-perimeter of any triangle, equals to the sum of its sides, that is to say, to A plus B plus C over 2. Okay, so we will find out now the semi-perimeter of our triangle ABC, according to the formula of the semi-perimeter, that the semi-perimeter actually equals to the sum of the sides of any triangle over 2. So the semi-perimeter of our triangle ABC, according to the formula for the semi-perimeter, S will be equal to A plus B plus C, that is the sum of its sides, over 2. Okay, so the semi-perimeter of our triangle ABC will be equal to A, that is 13 units, plus B, that equals to 15 units, plus C, that equals to 14 units, all divided by 2. That is the semi-perimeter of our triangle ABC. So actually 13 plus 15 is 28, and 28 plus 14 equals to 42. So 42 over 2 equals to 21 units. So the semi-perimeter of our triangle ABC equals to 21 units. Okay? So after we found out that the semi-perimeter of our triangle ABC equals to 21 units, we can calculate the area of triangle ABC by the following formula. The semi-perimeter, the area of any triangle equals to the root of S. S is the semi-perimeter times S minus A. A is the size of one of the triangle's sides times S minus B. Again, S is the semi-perimeter and B is the size of one of the triangle sides times S minus C. Okay, so the area of any triangle equals to the root of S times S minus A times S minus B times S minus C. Okay, so according to this formula, we can calculate the area of our triangle ABC, because we actually know that A equals to 13 units, B equals to 15 units, and C equals to 14 units. And we also found out that S, the semi-perimeter of our triangle ABC, equals to 21 units. Okay, so actually, as you can see, we have the values of all the variables of this formula, and the only thing that is left is to substitute S by 21, substitute A by 13, B by 15, and C by 14 units. So we will do it now, and we will get that the area of triangle ABC, our triangle, will be equal to the root of S is 21 units times S minus A is 21 minus 13 times S minus B is 21 minus 15 times S minus C is 21 minus 14. Okay, so the area of our triangle ABC equals to the root of this expression. 21 minus 13 is 8, 21 minus 15 is 6, and 21 minus 14 is 7. So I will write it down. So we will get that the area of our triangle ABC will be equal to the root of 21 times 8 times 6 times 7. Okay? The area of triangle ABC equals to the root of 21 times 8 times 6 times 7. So the outcome of this multiplication is 7,056. So the area of triangle ABC equals to the root of 7056, and the root of 7056 equals to 84 square units. So the area of triangle ABC according to the new formula equals to 84 square units. Okay, again the area of triangle ABC equals to 84 square units. So actually, after we found out the area of triangle ABC, we will find out the area of the green circle. That is actually the question of this lecture, to find the area of the green circle. So first of all, we will define the center of the green circle as point O. Point O is the center of the green circle, and then we will connect together by a straight line points A and O. And we will also connect together by a straight line points B and O. And we will connect together by a straight line points O and C. Okay, so actually we created three triangles, triangle AOB, triangle AOC, and triangle BOC, and the sum of those three triangles, the sum of the areas of those three triangles equals to the area of the big triangle, triangle ABC, because triangle ABC contains those three triangles exactly. Okay, in the next step we will draw three radiuses of the green circle that starts from the center of the circle and touches the launch points of the circle that are points D, E, and F. So the first radius starts from the center of the circle, that is to say from point O, and touches the launch point, that is point D. Okay, so the radius will be defined when we define this small r. So actually this radius is drawn to the launch point, that is point D, and then we will draw the second radius from the center of the circle to point E, that is the launch point between tangent AC and the green circle. Okay, Again, the second radius starts from the center of the green circle, that is to say from point O, and touches the circle at point E, that is the launch point between tangent AC and the circle and the green circle. And we will draw also the third radius from the center of the circle to point F, that is the launch point between tangent BC and the green circle. Okay, so we drew three radiuses that start from the center and touches the launch points of the circle, that are points D, E, and F. And we have a rule, I will call it rule number 1. According to rule number 1, a tangent to a circle, a tangent to the circle tangent to the circle is perpendicular to the radius drawn to the launch point. So I will read rule number 1 again. Rule number 1 states that a tangent to the circle is perpendicular to the radius drawn to the launch point. So actually, according to rule number 1, whenever you draw a radius that is drawn to the launch point or touches the launch point, then that radius will be perpendicular to the tangent. So this radius is drawn to the launch point, point D. Actually, it touches the launch point, point D. Therefore, that radius will be perpendicular to the tangent AB. That is to say, this is a right angle, and also this is a right angle, according to rule number 1. And the same thing we have about the other radius. This radius is also drawn to the launch point, point E. Actually, it touches the launch point, point E. Therefore, according to rule number 1, this angle will be a right angle, and this angle also will be a right angle, because the radius is perpendicular to its tangent AC, or the tangent is perpendicular to the radius R. It is the same thing to say that the tangent is perpendicular to the radius, or the radius is perpendicular to the tangent. Okay? And we have the third radius, this radius, that is also drawn to the launch point, that is point F. Actually, it touches the launch point, point F. Therefore, this radius is perpendicular to its tangent BC. That is to say, this is a right angle and also this is a right angle. Okay? So in the next step we will create an equality that I have already mentioned. The equality will be that the sum of the areas of the three small triangles, that is to say the area of triangle AOB plus the area of triangle AOC plus the area of triangle BOC, equals to the area of the big triangle, that is triangle ABC, that we have already found out that the area of triangle ABC equals to 84 units. Okay, so the equality is again that the area of triangle ABC, that is equals to 84 square units, equals to the sum of the areas of the three small triangles, that is to say the area of triangle AOB plus the area of triangle AOC plus the area of triangle BOC. Okay, again I repeat on the equality that states that the area of the big triangle ABC that we have already found out that is equal to 84 square units is equal to the sum of the areas of the three triangles, triangle AOB plus the area of triangle AOC plus the area of triangle BOC. Okay, because triangle ABC contains exactly the three small triangles, triangle AOB, triangle AOC, and triangle BOC. Okay, so what is the area of triangle AOB? The area of this triangle AOB equals to the base of the triangle, that is AB, times the height to the base. The height must create 90 degrees with the base, so the height of triangle AOB is actually the radius of the green circle, because this radius creates 90 degrees with the base AB. Therefore, the radius is the height of triangle AOB. So it is AB times R over 2. So we found out that the area of the small triangle AOB equals to the base, that is AB, times the height to the base, that is the radius of the green circle, over 2. Okay, and what is the area of triangle AOC? The area of triangle AOC will be equal to the base of triangle AOC, that is actually AC, times the height to the base. The height must create 90 degrees with the base. Then indeed the radius creates 90 degrees with the base AC, because this is a right angle and this is also a right angle. Therefore, the height of triangle AOC is the radius of the green circle, so it is the base AC times R over 2. Again, the area of triangle AOC equals to the base AC times the height to the base, that is the radius of the green circle, over 2. And what is the area of triangle BOC? The area of triangle BOC equals to the base of triangle BOC, that is actually BC, times the height to the base. Again, the height must create 90 degrees with the base BC, and indeed the radius of the green circle creates 90 degrees with the base, because this is a right angle and this is a right angle, so the height of triangle BOC is the radius of the green circle over 2. So the area of triangle BOC equals to the base BC times the height to the base, that is the radius of the green circle, over 2. Okay? And so what is AB? AB is actually equals to A. AB equals to A according to our definition. So the area of triangle AOB equals to A times the height, that is the radius, over 2. Okay? AB equals to A, so the area of triangle AOB equals to A times the radius over 2, plus the area of triangle AOC. So what is AC? AC equals to C according to our definition. So it is actually C times the radius of the green circle over 2. Okay, so the area of triangle AOC equals to the base C times the height to the base, that is the radius, over 2. And the area of triangle BOC equals to BC, and BC equals to B according to our definition, so it is B times the height to the base, that is the radius, over 2. So the area of triangle BOC equals to the base B times the height to the base, that is the radius of the green circle, over 2. Okay, so here we will take a common factor R over 2 as we will take R over 2 as a common factor of this expression. Okay, so after we took R over 2 as a common factor, after we took R over 2 out of as a common factor of this expression, we will get in the brackets, what is left is A plus C plus B. Okay, we got that 84 equals to R over 2 times A plus C plus B. Okay, so, but what is the value of A? A equals to 13 units. It is given us in the question. Okay, A equals to 13 units, and C equals to 14 units, and B equals to 15 units. So in total we got that 84 equals to R over 2. In the brackets we have 13 plus 14 plus 15. So 13 plus 14 is 27, and 27 plus 15 is 42. So I'll write it down. We got that 84 equals to R over 2 times 42. Okay, 84 equals to R over 2 times 42. Here 42 over 2 is 21, so we got that 42 equals to 21 times the radius. So the radius of the green circle, here we will divide this equality by 21 in order to get the radius of the circle. So the radius of the circle will be equal to 84 over 21. The radius of the green circle equals to 84 over 21. 84 over 21 is 4. So we got that the radius of the green circle equals to 4 units. Okay? So we actually found out that the radius of the green circle equals to 4 units. After we know the value of the radius, it is very easy to find out the area of the green circle. So the area of any circle equals to pi times the radius of that circle squared. Okay, the formula for the area of any circle equals to pi times the radius of that circle squared. And we know that r equals to 4 units, so we can substitute r by 4 units. And we will get that the area of the green circle will be equal to pi times, we'll substitute r by 4, pi times 4 square, and pi times 4 square equals to 16 pi. So the area of the green circle equals to 16 pi square units. Or in terms of numbers, the area of the green circle equals to 50.265 square units. Okay, so the area of the green circle equals to 16 pi square units, or in terms of numbers, the area of the green circle equals to 50.265 square units. Okay, so in the next step we will find the area of triangle ABC in a second way. So I will present you a second method to find out the area of triangle ABC. Okay, second method to find out the area of triangle ABC. Okay, again I will present you a second method to find the area of triangle ABC. Actually, we will implement the law of cosines on triangle ABC in order to find out its area. So, what is the law of cosines? The law of cosines apply to any triangle. That is to say, you can use it in any triangle. So I will write it down that the law of cosines is true for any triangle. So in any triangle, if you have a triangle ABC, and we know that side AB of this triangle is A units in size. Side BC of triangle ABC equals to B units in size. And side AC of triangle ABC equals to C units in size. And we also know that the angle between side AB and side BC is theta. Then, according to the law of cosines, C squared equals to A squared plus B squared minus 2 times A times B times cosinus theta. Again, according to the law of cosines, in any triangle, the following equality is true, that C squared equals to A squared plus B squared minus 2 times A times B times cosinus theta. Okay? So, we actually can implement the law of cosines in our triangle ABC, because we know that A equals to 13 units in our triangle ABC, B equals to 15 units, and C equals to 14 units. And the only missing variable in this equality is cosinus theta. So we will put the data inside this equality and we will find out the value of cosinus theta. Okay, so what is the value of C squared? C equals to 14, so C squared is 14 squared, and 14 squared is 196, equals to A squared. A equals to 13, so A squared is 13 squared, and 13 squared is 169, plus b square. B equals to 15 units, and b square is 15 square. 15 square is 225 minus 2 times a times b times cosinus theta. So it is minus 2 times 13 times 15 times cosinus theta. That is actually 390 or minus 390 cosinus theta. So in total we got that 196 equals to 169 plus 225 minus 390 cosinus theta. So 169 plus 225 equals to 394 minus 390 cosinus theta. That equals to 196. So here we will we will add to this equality 390 cosinus theta, and we will subtract from this equality 196, and we will get that 390 cosinus theta equals to 198. Okay, we got this equality that states that 390 cosinus theta equals to 198. Here we will divide this equality by 390 in order to get the value of cosinus theta. So cosinus theta will be equal to 198 over 390. Okay, cosinus theta equals to 198 over 390, and actually cosinus theta equals to 0.507692. So we found out the value of cosinus theta. We found out that cosinus theta equals to 0.507692. Now, in order to find out the value of theta, we will use the inverse function of cosinus in order to get the value of theta. The inverse function of cosinus is arc cosinus. So actually arc cosinus of 0.507692 equals to the value of theta, and the value of theta is 59.49 degrees. We got that the value of theta equals to 59.49 degrees. Okay, we found out the value of theta. After we found out the value of theta, it is very easy to find the area of triangle ABC, because we have actually the sizes of all the sides of triangle ABC. We know that in triangle ABC BC equals to B, that equals to 15 units. AB equals to A, that equals to 13 units. AC equals to C, that equals to 14 units. And we found out that the value of theta equals to 59.49 degrees. Okay, we found out the value of theta, and in the next step we will draw a perpendicular to side BC of triangle ABC. So this angle is a right angle and this angle is a right angle. So actually we created a right triangle, and because of the fact that the red line is perpendicular to BC, it is actually the height of triangle ABC. The height to the base BC is the red line, so I will define it as h, that is the height of triangle ABC. And we know that in any right triangle, sinus of 59.49 degrees equals to the edge over the hypotenuse A. Okay, in any right triangle, the value of sinus is the side, the relationship between the side that is in front of that angle over the hypotenuse of that right triangle. So it is edge, that is the side that is in front of angle, this angle, over the hypotenuse. And actually sinus of 59.49 degrees equals to 0.8615, and it equals to h over a, but we know that a equals to 13, so we can substitute a by 13, so it is h over 13. So the height of triangle ABC will be equal to 13 times 0.8615. Okay, so the height of triangle ABC when the base is 15 units equals to 0.8615 times 13, and it is equal to 11.2 units. Okay, so we actually found out that the height of triangle ABC equals to 11.2 units. When the base B equals to 15 units. The base equals to 15 units, and the height of triangle ABC equals to 11.2 units, and the base equals to 15 units. and we know that the area of any triangle equals to the base times the height to the base over 2. So the area of triangle ABC, and in general of any triangle, equals to the base of the triangle times the height to the base over 2. That is the formula for the area of any triangle. It is the base of the triangle times the height to the base over 2, and as you can see here, the height to the base creates 90 degrees with the base, so h is indeed the height of triangle ABC. Okay, so the area of triangle ABC will be equal to the base, that is 15 units, times the height to that base that creates 90 degrees with the base, that is actually 11.2 units over 2. Okay, so we found out that the area of triangle ABC equals to 15 times 11.2 over 2. And 15 times 11.2 is 168 over 2. So 168 over 2 is 84 square units. Okay, 84 square units. Okay, so we actually found out in a second way that the area of triangle ABC equals to 84 square units. Okay, so in the next step we will find out the area of triangle ABC in a third way. Okay, we'll find out the area of this triangle ABC in a third way. So our third method to find out the area of triangle ABC. Third method to find out the area of triangle ABC. Okay, again I will present to you a third method to find out the area of triangle ABC. Okay, in the third method we will divide triangle ABC to two right triangles. Okay, the first part of triangle ABC, after we divide it to two right triangles, will be the right triangle with sides of 13 units. This is the hypotenuse. Then we have 12 units, and we have 5 units, and this is a right angle. So this is the first part of triangle ABC after we divide it to two parts, to two right angles, to two right triangles. This is the first right triangle, and in order to prove that this is indeed a right triangle, we will prove that this triangle obeys to the Pythagorean theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So we will check if 13 square equals to 5 square plus 12 square. So 13 square is 169 equals to 12 to 5 square is 25 plus 12 square is 144, and indeed 144 or 25 plus 144 is indeed equal to 169. So this is a right triangle, and then we will create the second half of triangle ABC, or the second right triangle. This side is 12. So actually we prove that the height of triangle ABC equals to 12 units when the base of the triangle ABC is 14 units. And the area of any triangle equals to the base of the triangle times the height to the base over 2. So we'll find out that the area of triangle ABC equals to 14, that is the base of the triangle ABC, times the height, that is 12 units, over 2, and 14 times 12 over 2 is actually 84 square units. Okay, so this side of triangle, the half part of triangle ABC is 9 units, and this side, the hypotenuse, equals to 15 units. And this is a right angle. And again, we will prove that this triangle is indeed a right triangle by checking if 15 square equals to 9 square plus 12 square. So 15 square is 225, 9 square is 81, plus 12 square is 144, and indeed 81 plus 144 equals to 225. So we actually proved that if we divide triangle ABC to two parts, to two right triangles, then the height of triangle ABC is 12 units when the base is 14 units. So, because if we combine together these two right triangles, we will get exactly the original triangle, triangle ABC, because this side will be equal to 9 plus 5 is 14 units, this side equals to 13 units, and this side equals to 15 units. It is exactly the same triangle, triangle ABC. And again, in this way, we proved that if the base of triangle ABC is 14 units, then the height to the base is 12 units, and in this way we can calculate the area of triangle ABC. Because as I have already mentioned, the area of any triangle equals to the base of the triangle times the height to the base over 2. Okay, so the area of triangle ABC the area of triangle ABC equals to the base of the triangle times the height to the base over 2. So the base of triangle ABC equals to 9 plus 5, that is 14 units, times the height to the base is 12 units, and again the height must create 90 degrees with the base, and indeed 12, the side that is equals to 12 units, indeed creates 90 degrees with the base, because this is a right angle and this is a right angle. So if we combine together these two right triangles, the height that is 12 units indeed creates 90 degrees with the base. Okay, so it is 14 times 12 over 2. So we found out that the area of triangle ABC equals to 14 times 12 over 2. 12 over 2 is 6. So we got that the area of triangle ABC equals to 14 times 6, and 14 times 6 is 84 square units. So we actually found out in a third way that the area of triangle ABC equals to 84 square units. Okay, and actually, if we want to find out the radius of the green circle, we can use the first way. We can divide triangle ABC to 3 small triangles, and we will create the equality that states that the sum of the areas of the 3 small triangles equals to the area of the big triangle, that is triangle ABC, that equals to 84 units. And the only missing variable that we will have in this equality is the radius of the green circle. So by solving this equality, we will find out the radius of the green circle, and after we know the value of the radius of the green circle, the area of any circle equals to pi times the radius squared. So we will square the radius that we found, and we will multiply it by pi, and we will find out the area of the green circle. Okay, so now I will present you a second way to find out the radius of the green circle. The radius, and then after we know the radius, it is very easy. The value of the radius, or the size of the radius, it is very easy to find out the area of the green circle, because the area of any circle equals to pi times the radius squared. So we will square the radius, and we will multiply it by pi, and we will find out the area of the green circle. So I will present you the second method to find out the radius of the green circle. Again, I will present you second method to find the radius of the green circle. Okay, so actually we can use this method in any circle that it is inscribed inside a triangle. So in any circle that it is inscribed inside a triangle, the following formula is true. Okay, in any circle that is inscribed inside a triangle, the following formula is true, that the radius of that circle will be equal to the area of the triangle that contains that circle over the semi-perimeter of that triangle. S is the semi-perimeter of the triangle that equals to the sum of its sides over 2. We actually have already found out that the semi-perimeter of triangle ABC equals to 21 units. We can do the same calculation again, and we will find that S equals to 13 plus 15 plus 14 over 2. It is actually 42 over 2 equals to 21 units. Okay, so S equals to 21 units, and we have already found out in 3 different ways that the area of triangle ABC equals to 84 square units. Okay, the area of triangle ABC equals to 84 square units. And the semi-perimeter of triangle ABC equals to 21 units. So R equals to delta, that is the area of triangle ABC, over S, the semi-perimeter of triangle ABC. So it equals to the area of triangle ABC, that is 84 square units, over the semi-perimeter of triangle ABC, that is 21 units. That is to say 24 over 84 over 21 equals to 4 units. So actually the radius of the green circle equals to 4 units. And we know that the area of any circle, the formula for the area of any circle equals to pi times the radius of that circle, squared. Again, the formula for the area of any circle equals to pi times the radius of that circle squared. So we have already found out that the radius of the green circle equals to 4 units. So we will substitute r by 4 in this formula, and we will get that the area of the green circle equals to pi times r. R is 4, so pi times 4 square equals to 16 pi square units, or the area of the green circle in terms of numbers equals to 50.265 square units. Okay, so I will repeat again. The area of the green circle equals to 16 pi square units, or in terms of numbers, the area of the green circle equals to 50.265 square units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the area of the green circle. We know that the circle is inscribed inside a triangle. That is to say, the triangle is tangent to the circle at 3 points. Side AB is tangent to the circle at point D. That is to say, point D is the launch point between tangent AB and the green circle. And we also know that side AC of triangle ABC is tangent to the circle at point E. That is to say, point E is the launch point between tangent AC and the green circle. And also side BC of triangle ABC is tangent to the circle at point F. That is to say, point F is the launch point or the point of tangency between the tangent BC and the green circle. Okay? And we also know that AB equals to 13 units, so we defined AB as A equals to 13 units, and we also defined BC as B, and we know that B equals to 15 units, and we defined AC as C, and we know that C equals to 14 units. Okay, and we want to find out the area of the green circle. So, first of all, we defined the term of semi-perimeter. What is the semi-perimeter? The semi-perimeter of any triangle equals to the perimeter of the triangle, that is actually the sum of its sides over 2. Okay, so the semi-perimeter of any triangle equals to the perimeter of the triangle over 2, and we found out the semi-perimeter of our triangle ABC. So actually, I'll explain again what is semi-perimeter. In any triangle, the semi-perimeter of this triangle, that can be any triangle, equals to the sum of its sides, that is A plus B plus C, over 2. That is the semi-perimeter of any triangle. It is the perimeter of the triangle over 2. A plus B plus C over 2. That is S. S, the abbreviation for the semi-perimeter. That is to say, S is the semi-perimeter of the triangle. Okay, so we found out the semi-perimeter of our triangle ABC, that is actually equals to A plus B plus C over 2. We know that A equals to 13 units, B equals to 15 units, and C equals to 14 units. So the semi-perimeter of triangle ABC, our triangle, equals to 42 over 2. That is 21 units. So the semi-perimeter of our triangle ABC equals to 21 units. And then we used a special formula in order to find out the area of triangle ABC. That formula is valid for any triangle. That is the formula for the area of any triangle. That area of any triangle equals to the root of S. S is the semi-perimeter, and A, B, and C is the size of the sides of that triangle. In our example, we know that S, the semi-perimeter of our triangle, equals to 21 units, and we know that A equals to 13 units, B equals to 15 units, and C equals to 14 units. So we put the data inside this formula, and we found out that the area of triangle ABC equals to 84 square units. Okay, that is the first way to find out the area of triangle ABC. The area of triangle ABC equals to 84 square units. Okay, and then we actually found the radius of the green circle. First of all, we defined the center of the green circle as point O. Then we connected together points A and O by a straight line. We connected together points B and O by a straight line. And we connected together points C and O by a straight line. Then we draw 3 radiuses from the center of the circle to the launch points of that circle, that is to say to points D, E, and F. And actually the 3 radiuses that we drew starts from the center of the circle, and they are drawn to the launch points that are D, E, and F. This radius is drawn to the launch point D, and the same thing is about this radius that is drawn to the launch point E, and also this radius is drawn to the launch point F. And we have rule number 1 that states that a tangent to the circle is perpendicular to the radius drawn to the launch point. So whenever you draw a radius that is drawn to the launch point and touches the launch point, then that radius will be perpendicular to its tangent. So that is to say, this radius is perpendicular to its tangent AB. That is to say, this angle is 90 degrees and this angle is also 90 degrees. And we have also the second radius that is tangent to its tangent, and that is drawn to the launch point E. Therefore, according to rule number 1, that radius is perpendicular to its tangent AC. That is to say, this angle is 90 degrees and this angle is also 90 degrees. And also the third radius that we draw is drawn to the launch point F. Actually, it touches the launch point F. For that reason, according to rule number 1, that radius is perpendicular to its tangent BC. That is to say, this angle is a right angle, and this angle also is a right angle. Okay, and then we created the equality that states that the sum of the areas of the 3 small triangles, that is to say triangle AOB plus the area of triangle AOC plus the area of triangle BOC, will be equal to the area of the big triangle ABC, that is equal to 84 square units, because the triangle ABC contains exactly the 3 small triangles, triangle AOB, triangle AOC, and triangle BOC. So the sum of the areas of the small triangles equals to the area of the big triangle, that is actually 84 square units. Okay, so we created this equality that the sum of the area of triangle ABC that equals to 84 units equals to the sum of the areas of the three triangles, and the area of this small triangle AOB equals to the base of the triangle times the height to the base. The height creates 90 degrees with the base, so it is actually AB times R over 2, and the same thing is over as about this triangle. The area of this triangle will be equal to the base of the triangle, that is AC, times the height to the base, that is the radius over 2, and the area of this small triangle equals to the base of the triangle, that is BC, times the height to the base, that is the radius over 2. Okay, so actually the only missing variable that we have here is the radius of the green circle. We have all the other variables here. So by solving this equality, we found out the radius of the green circle. We found out that the radius of the green circle equals to 4 units, and then we know that the area of any circle equals to pi times the radius squared. So we know that R equals to 4 units, so we can substitute R by 4 in this formula, and we found out that the area of triangle ABC equals to 16 pi square units. So in terms of numbers, the area of triangle ABC equals to 50.265 square units. Okay, so this was the first method to find out the area of triangle ABC, and also to find out the radius and the area of the green circle. Then I presented you a second method to find out the area of triangle ABC. We used the law of cosines in order to find out the area of triangle ABC. According to the law of cosines that is valid for any triangle, C square equals to A square plus B square minus 2 times A times B times cosinus theta. Again, C square equals to A square plus B square minus 2 times A times B times cosinus theta. And we know that A equals to 13 units, B equals to 15 units, and C equals to 14 units. So the only missing variable that we have here is cosinus theta. So by solving this equality, we found the value of cosinus theta. We found that cosinus theta equals to 0.507692. So we use the inverse function of cosinus, or the opposite function of cosinus, that is R cosinus, in order to find out the value of theta. So R cosinus of 0.507692 equals to 59.49 degrees, or the value of theta is 59.49 degrees. So after we found out the value of theta, it is very easy to find out the area of the triangle, because we know the sizes of all the sides of triangle ABC, and the only missing variable here is the height to the base BC, that equals to 15 units. So we go perpendicular to side BC. So this angle is a right angle, and this is a right triangle, and in any right triangle we know that sinus of any angle equals to the relationship between the side that is in front of that angle over the hypotenuse of the triangle. So the sinus of 59.49 degrees equals to H over A, and sinus 59.49 is 0.8 8615, and A equals to 13 units. So the only missing variable here is h, that is the height of triangle ABC. So we found out that h, that is the height of triangle ABC, equals to 11.2 units. Okay, so after we know that the height equals to 11.2 units, we know that the area of any triangle equals to the base of the triangle times the height of the base over 2. And we know that the base equals to 15 units, the height equals to 11.2 units. So we put the data inside this equality, and we found out that the area of triangle ABC equals to 84 square units. Again, the base equals to 15 units, the height equals to 11.2 units. So the area of triangle ABC equals to 84 square units. Okay, so that was the second method to find out the area of triangle ABC. And then I presented to you a third method to find out the area of triangle ABC. And according to this method, we splitted triangle ABC to two parts, to two right triangles, and in this way we proved that the height of triangle ABC is 12 units when the base is 14 units. Okay, so if we know that the height is 12 units and the base is 14 units, then the area of any triangle equals to the base times the height over 2. So it will be 14 times 12 over 2. Okay? So, again, the area of any triangle equals to the base times the height over 2. And we have already proved that if the base of the triangle is 14 units, then the height to the base is 12 units. So the area of triangle ABC equals to the base times the height over 2. That is to say, the area of triangle ABC according to the third way is also equals to 84 square units. Okay, then I presented to you a second method to find out the radius of the green circle. According to this method, we know that in any circle that it is inscribed inside the triangle, the following formula is true, that the radius of that circle equals to the area of the triangle that contains that circle over the semi-perimeter of the triangle. And we have already found out that the semi-perimeter of our triangle ABC equals to 21 units, and we found out in 3 different ways that the area of triangle ABC equals to 84 square units. Okay, so we have all the data in order to find out the radius of the green circle. Delta equals to 84 square units and S equals to 21 units. So 84 over 21 is 4, so the radius of the green circle equals to 4 units. And after we know the value of the radius, it is very easy to find out the area of the circle, because the area of any circle equals to pi times the radius of that circle squared. So here we know that the r equals to 4 units, so we can substitute r by 4 in this formula, and we got that the area of the green circle equals to pi times the r is 4, so it is pi times 4 square. The area of the green circle equals to 16 pi square units, or in terms of numbers, the area of the green circle equals to 50.265 units. Again, the area of this green circle equals to 16 pi square units, or in terms of numbers, the area of this green circle equals to 50.265 square units. Okay, thank you very much.